Good morning, ladies and gentlemen. Good morning to all the eminent dignitaries in the audience. Good morning to all my dear colleagues and friends, and good morning to all the delegates. It is indeed a privilege for me to stand over here and deliver this presentation on smart and sustainable solutions in the transportation segment and the role that stainless steel plays in achieving that. Now, when we look at a smart city, so what are we trying to achieve with smart cities? One, we are trying to have energy conservation and improvement in efficiency. We are looking at how to reduce the adverse effect on environment. And finally, how all these gels into making a long and a sustainable solution. Now, there are many ways of achieving a smart city, but we believe that transportation is one of the key players in how we could achieve all the three objectives. And when we look at transportation in India, then basically the buses form the backbone of the urban mobility. It constitutes over 90% of the public transportation in the country. So how do we develop smart buses? And here I would like to borrow an article from a Grant Thornton study, which talks about smart transportation transforming Indian cities. So they talk of three things. One, having a connected vehicles through Internet of Things, having electric vehicles, and finally having the right vehicle technology. And when we look at vehicle technology, there are three things they mention. One, the vehicle must have superior crash resistance. It has to have an enhanced driving comfort and safety, featuring usage of high-strength steel. And this steel should have a combination of strength, ductility, toughness, and fatigue properties. So let us see what the smart cities around the world have adopted. If we look at the top 10 smart cities across the world, then we find that in terms of buses, they have adopted stainless steel as a primary material of fabrication. So stainless steel is not a new concept as such. In fact, it came into being in 1940s in the North Americas. It spread to Europe in 1980s in Italy. And in 1990s, it spread to Scandinavia, Belgium, Germany, Netherlands. In 2000, it was adopted in Australia, China, and Asia. And finally, in 2016, 2017, we are seeing footprints of stainless steel in India as well. Just to share with you some of the global scenario, what the major bus body manufacturers are doing. Volvo Finland, they have been operating stainless steel buses since 1991. And here we have stainless steel both for the superstructure as well as the panel, and for the underframe components as well. If we look at Australia, here also the buses are made out of stainless steel. Most important thing to remember is that the usage of stainless steel results in a weight saving of 700 kg per bus, and when there is weight reduction, there is a concomitant fuel savings. So fuel savings is almost around $2 per kilometer in petrol. Further, the reduced bus weight, it also enables higher revenue generation in terms of additional carriage carrying capacity of passengers. And finally, and most importantly, maybe the production time was also reduced by 15%. These are some of the the examples of what we are having across the world. So Greyhound in USA, Silver Eagle in UK, they are all made out of stainless steel. Point to remember here is they are all using unpainted stainless steel. This is Optare in UK, and Scania, as you would be knowing, they have also opened up a shop in Bangalore. So here also they are using stainless steel. Electric buses is something, it's a new concept, but there is a lot of focus by the government on electric vehicles. And let me tell you, across the world, all electric buses are made out of stainless steel. Primary reason being that they want to reduce the weight and therefore improve the life of the lithium-ion battery, which is extremely costly. So why stainless steel? One, before we go into the depths of stainless steel, let us look at what are the major parameters or major factors which come into play while designing the vehicles. First and foremost is safety. Safety in terms of having a higher crash resistance, safety in terms of having a higher fire retardant characteristics. Moving over longer life, corrosion is a major problem in India, and therefore we need to have bus bodies which can last 12 or maybe more than that. Lower maintenance. If you have a corrosion-resistant material, of course, the maintenance cost come down. There's no cleaning or repairing that needs to be done. Design, use of high-strength steel basically enables a reduction in thickness of the components and therefore reduction in the weight of the bus body, leading to significant fuel savings. And finally, all these dovetails into having a lower life cycle cost, a lesser downtime, and a higher throughput. So if you look at the crash resistance or the impact resistance, stainless steel grade, we have looked at ferritic stainless steel because this is a grade which is widely used for fabricating of bus structures. So in terms of, if we compare that with mild steel or the existing material which are being used, stainless steel offers almost, I would say, 30% more crash resistance as compared to existing material. This is a typical example of what happens in India. There is overturning of buses, there is head-on collisions, and it is in these cases that stainless steel plays a major role in saving the life of the bus, saving the lives of the passengers. And these are some of the, the statistics which I'd like to share with you. A study which was done by the Ministry of Road Transport and Highways in 2016, and it has observed that 8.3% of all accidents in India are caused by buses, out of which 10,450 is the total number of fatal accidents caused by buses. There was a study which was done in May 2011, and it states that more than 25% of all crashes are due to overturning and head-on collisions, and out of which 11 to 14% are fatal accidents. Therefore, when we look at the safety, this is where stainless steel comes into the picture. This is where stainless steel offers the best-in-class solution. If you look at the fire-resistant characteristics, vis-a-vis carbon steel, above 300 degrees centigrade, stainless steel is able to still retain its strength, whereas there is a significant, decrease in strength of carbon steel or aluminium, and therefore there is a crumbling of structures which happen, which traps the passengers and therefore cause fatalities. So here also stainless steel is the best option. And therefore, as you would notice, in the railways, Indian railways have adopted stainless steel for all their passenger carrying coaches, I would say, be it the metros, be it the EMUs or DMUs, or be it the long distance, the Shatabdis or the Durantas or the Rajdhanis, they are all made out of this ferritic stainless steel which we have proposed for the bus body. If you look at the longer life, India is a highly corrosion prone country. So this is the corrosion hut of India, which states that all the coastal regions undergo extreme severe corrosion, and the corrosion is to the order of greater than 0.25 millimeters per year. Now this figure is important because if you look at the structures of bus bodies, the panels of bus bodies, they are almost 1 or 1.2 millimeters in thickness. Therefore, over a period of 3 to 4 years, the strength of the bus body, the strength of the panel reduces, there is significant corrosion. And I would like to show you some photographs. These were photographs taken by us in Bangalore, and this is the condition of the bus bodies after 3 to 4 years of operation. And you can see because of significant amount of corrosion, the panels undergo huge amount of degradation. And therefore, these panels after 3 to 4 years are not safe for use, for the passengers. If you look at the global, what is happening in the global scenario, all the panels are made out of this grade called ferritic stainless steel. This is the lowest cost utility ferritic stainless steel called 409M in India. And it has got a significant amount of strength as compared to normal mild steel. And therefore, it lends to reduction in the thickness of the components, making it lighter. If we compare that with aluminium, the modulus of elasticity of stainless steel is almost 3 times that of aluminium. And therefore, if you are using, say, 3.15 mm thickness of aluminium, which is currently used by all state road transport corporations, you can go ahead with 0.9 or 1 mm of stainless steel. And therefore, there is a common concern that use of stainless steel as compared to aluminium will increase its weight. But then, because of the reduction in thickness by 1/3, it compensates for the decrease in specific gravity, and therefore the weight remains more or less the same. But the cost comes down significantly. If you look at the structures, this is where stainless steel gives significant amount of benefit in terms of reduction in weight. In fact, here also globally, Volvo, Scania, they're all using this grade called 409M or 1.4003. And here the yield strength of these stainless steel tubes is more than 50% of the carbon steel tubes that are being used, YST240. So what happens is that we are able to reduce the weight of the structure by as much as 20 to 25%. This gives an enormous amount of fuel savings, and I will show you through case studies, actual case studies in India, what is the fuel saving that is coming to. It increases the tire life, and it also increases the life of the buses. Today, we have a regulated bus life of 10 to 12 years, but with stainless steel, it can be increased further to maybe 15 or 20 years. So therefore, summarizing why stainless steel in buses: one, its body retains its original strength because of its high corrosion resistance. It provides the maximum amount of safety to passengers, lowering of weight by almost 20%, and therefore savings on fuel, longer life, reduced cost. It looks aesthetically beautiful, aesthetically very attractive. More importantly, stainless steel is a green steel. So whenever we are talking of smart cities, whenever there is a focus on environmental concerns, stainless steel is the solution. And finally, it is a sustainable material, lending or making the bus bodies or bus body owners have a significantly lower life cycle cost as compared to any other alternate materials. So these are some of the examples of stainless steel being used in bus bodies in India. So we have external panels made out of 409M and a grade called J4, which is 200 series of stainless steel. We have the inner panels made out of SS430 in bright finish. The components, there are many cases of bus bodies moving over to or adopting stainless steel superstructure. That is also with 409M tubes. We have the grab poles, the stanchions, the inner panels, the windshields, the window rails in SS304 or J4 in polished form. The checkered sheet. Now this is another product which we have come out with, and it provides immense benefit to the end users. So these are used for footsteps and luggage carriers in bus bodies in Indian railways. Now if you look at a conventional checkered sheet made out of aluminium versus the stainless steel checkered sheet, what happens is that aluminium, being a softer material, the profile wears out after 3 to 4 years. And therefore, the purpose for which it is put, the anti-slip characteristics are lost. Whereas if you look at stainless steel, it is a highly wear-resistant material, it's a highly corrosion-resistant material, and therefore it could be used for almost, say, 20 to 30 years without any maintenance or repair. The cost is another advantage. The cost comes down significantly when you are using stainless steel checkered sheet as compared to aluminium. So this is the cost advantage. We have worked with several bus body manufacturers in South, the various state road transport corporations, and what we have found out is that usage of stainless steel checkered sheets, it reduces the average procurement cost by almost 9,000 rupees per bus. And normally, the tender volume of some of the larger state road transport corporations is almost 1,000 buses per annum. So this immediately results in a procurement cost savings of close to 1 crore. These are some of the references, the global references in Europe, where stainless steel is used as floors of, the rail cars, the bus bodies. This is in India. Indian railways have now switched over from aluminium checkered sheet to stainless steel checkered sheet. If you travel in Mumbai, if you look at the floors of the trains, they are all made out of stainless steel checkered sheet. If you travel in the LHB coaches like the Durantos and Shatabdis, near the doorway area, all floor material are in stainless steel checkered sheets. You can also use it for load bodies. If you are able to use in load bodies, there is a reduction in the weight by as much as 50%. So if you look at the life cycle cost benefits of stainless steel, I just want to spend a few minutes on this slide because this slide is important. I have taken a typical example where the weight of structure and panels is around 2100 2.1 tons with a non-stainless steel material. Usage of stainless steel reduces by around 400 kg, almost 400 kg. Normally, what we have observed is, and these are actual figures, the mileage of a non-stainless steel bus is around 5 kilometers per liter, whereas with an SS bus, you get around 5.32 kilometers per liter. And the normal distance which is traversed by any bus is around 400 kilometers per day. Therefore, the diesel savings per day comes to around 4 liters of diesel. With a cost of 65 to 70 rupees, per day savings on diesel amounts to around 280 rupees or close to 300 rupees per day. If you convert that into months, it is 9,000 rupees. If you convert that into year, it's 1 lakh. And the incremental cost with stainless steel tubes comes to around 80,000. So therefore, you're able to recover the amount within around 9 to 10 months. And after that, if you look at the overall cost savings, the total life cycle benefit with stainless steel bus over a period of 12 years comes to 13 to 14 lakhs. Now, these are some of the features of this estimated cost savings. One is the fuel, that is around 9 to 10 lakhs. If you look at the savings on account of repair and maintenance, stainless steel doesn't require any amount of repair and maintenance. So almost 2 lakhs is saved over a period of 2 years. Downtime, there is almost no downtime, and normally whenever there is a downtime, we find that around 1.5 lakhs rupees is lost. It's an opportunity cost which is lost when we are using carbon steel buses. And finally, we have also extended a scrap credit benefit to all the state road transport corporations. That means after the life of the buses, we are going to buy back the scrap and we have to offer the scrap credit. So therefore, even if you see it is 13 to 14 lakhs, ideally it could be more than that. So what are some of the case studies? In state road transport corporations, Andhra Pradesh, APSRTC, Karnataka State Road Transport, Telangana, Goa, Maharashtra State Road Transport, they have all adopted stainless steel buses, either in the trial phase or in the commercial phase. In terms of the private manufacturers, Volvo, Scania, Veeravana, Azad Coaches, KMS, SM Kanappa, they have all adopted stainless steel for their bus bodies. Just few case studies. This is a case study from Andhra Pradesh State Road Transport Corporation where they have developed this, just give me 1 minute here, where they have developed this ultra deluxe stainless steel bus body in stainless steel, and here the superstructure is in stainless steel tubes. They have got a weight reduction of 370 kg per bus. This is plying on the Srikakulam-Vizag route since November 2017. The trial run has been completed for 6 months. And this is the performance feedback which we have obtained from APSRTC. So increase in mileage with stainless steel bus is around from 5 kilometers per liter, it has increased to 5.3. So the cost savings, when considering a distance travel of around 400 kilometers per day, it's around 8,000 to 8,500 per month. The payback period is within 9 to 10 months. What is important to realize, what is the correlation between diesel saved, the distance run, and the weight reduction? So 2 to 2.5 liters of diesel is being saved for every 1 metric ton of weight reduction for every 100 kilometers of travel. And this is not only for India, this has been proved globally as well. So these are some of the structures. The second bus which was developed by APSRTC and which has been launched in March. Maharashtra Road Transport Corporation, they have converted the stainless steel, the panels, the roof, the floor in stainless steel. This was developed at the Dapodi workshop in Pune. And here they have used checkered sheet for the floors as well. This is the bus which was launched on the Pune-Solapur route on 20th February. If you look at Goa Road Transport, they have already adopted stainless steel in their tender specifications. The inner panels are made out of stainless steel. The stanchions, handrails are all in stainless steel. Veeravana, they are the first user of stainless steel tubes for their superstructure. They have developed these bus for the Kalpaka travels. And therefore, before I end, what I would like to highlight is that if you are going to have the safest, if you are going to have the smartest and sustainable journeys, we must get ourselves aligned with the world. And therefore, we must use stainless steel buses. Thank you.